Hey everyone, and welcome back to the YouTube channel. Today we're doing the 2018 Methods Exam 2. I hope that seeing me answer some of the questions on this paper can help you guys, especially if your teachers haven't taught you some of the content that well. And if you appreciate the fact that I'm doing this, make sure to drop a like on the video and subscribe to the channel. As a quick word of warning before I actually get into this paper, I do recommend that you try doing this paper first before you watch me do it, just so that when you're doing it as practice, you don't know the answers to all the questions. But with that said, let's just get straight into it. Alright, so I've got the Methods Exam 2 on my OneNote and I've got my pen here so I can annotate on the screen. And I also have a camera here filming my CAS as well, so you can see what I'm putting into my calculator. So with the multiple choice section on the Methods Exam, I usually like to finish this section as quickly as possible. So I usually try to get through 20 questions in about 30 minutes or so, but I used to be finishing it in less time than that as well. So with this first question we're asked to find the period of this function. I know that the period is going to be 2 pi on whatever is in front of x, so it's going to be 2 pi on 3, and I know that this is just going to be 3, so the answer is C. Our next question asks us to find the maximal domain of the function, where f is all real numbers except for 1. And so because it's all real numbers except for 1, I know that most likely it's going to be an x on the bottom of the fraction, so that's probably going to be A. So for these questions, I don't even have to do that many calculations because the answer is pretty much given in the question itself. So now with question 3, we've been asked to find the range of f, and f is this function 1 on x, and it goes from a including a to b not including b. So with this question, I think the trick is that since 1 on x is a decreasing function, 1 on b, since b is a bigger number, is actually going to be smaller than 1 on a. So therefore, we'll have 1 on b and 1 on a as the two numbers. But because a is smaller than b, therefore 1 on b is going to be smaller than 1 on a. And therefore, the range is going to be D, 1 on b to 1 on a. So now we've got question 4, which is a transformation question. And this question asks us to find the point A once it's been transformed from the graph of f to the graph of g. And they tell you that g of x is a half f of x minus 1. So what we know is that when we have an x minus 1 in the function, that means that the whole thing has been moved 1 to the right, because when we have x minus 1 inside the function, it's going to be 1 to the right. If it was x plus 1, it will be 1 to the left. So therefore, we know that the point A has to be moved from 3, 2 to 4 something. And then we also know that it has been halved, so it's going to be 4, 1. So the answer will be C. Now we've got question 5, which is asking us to find the stationary point on the graph of f when x equals -2. So for this one, I'll use my CAS. First, what I'll do is I'll put in this equation. So I'm going to do the derivative of this equation. And a quick shortcut for the derivative is shift minus, and that gives us the derivative. So I'm going to go ddx of x squared plus p on x. That gives us that. Now I'll do given that x equals -2. Equals -2, and then we'll solve this for 0 equals 0, comma, p. That gives us p equals -16. And just one thing from this sequence in the CAS, how I put this x equals -2 is I pressed Control equals, and then I used this this line here, which is given that, which is what we used in the question. So now we've got question 6. It tells us that f and g are two functions such that f of x equals 2x and g of x plus 2 equals 3x plus 1. So, and then they ask us what the composite function is. So if g of x plus 2 equals 3x plus 1, then I think that g of x is going to be 3x minus 2 plus 1. And we'll just work this one out. There's going to be 3x minus 6 plus 1 minus 5. And then we've got f of g of x, that is going to be 6x minus 10 because f of x is 2x. So now we're doing question 7. We've got let f of x be positive real numbers, and we've got a log function, and then we're given that f inverse of 1 is 8, the value of k is. So here we don't actually have to calculate the inverse function, we can just put in the opposite, because the x of the inverse, the x and y of the inverse function is going to be the y and the x of the normal function. So here what I'll do is I'll let 8 be x and 1 be f of x in this, and then just solve for k. So we've got 1 is equal to k times log 2 of 8, comma k. That gives us k equals a third. Okay, moving on to question 8, we've got our first integration question. So we've got if 1 to 12 g of x equals 5 and 12 to 5 g of x equals negative 6, then what's 1 to 5? So we've actually been given pretty much everything we need in this question. Now what we're looking for is, since we know 12 to 5 is negative 6, that means that 5 to 12 g of x dx is going to be just positive 6. So then now we're looking for 1 to 5 g of x. So what we have to do here is going to be 1 to 12 minus 5 to 12 g of x will probably give us our answer. So if 1 to 12 g of x equals 5 and 5 to 12 g of x equals negative 6, then we're going to minus these two to get 5 minus 6 to get negative 1. So question 9 tells us that a tangent to the graph of y equals log e to x has a gradient of 2, and then they ask us where the tangent will cross the y-axis. So the way I'll go about this is I'll get the derivative of y equals log e to x. I can probably do this in my head, but it doesn't matter. That gives us 1 on x. And then therefore the gradient of 2, we have to find the point on the graph where the gradient is going to be 2. So here I know that 1 on x is going to equal 2 when x equals half. So now what I'll do is I'll use the tangent equation on the CAS, going menu for 9, and I'll put in log 2x, comma x equals, comma x equals 1/2. That gives us 2x minus 1 is the tangent, which gives us the answer C. So now we've got question 10. This one is the function f has the property f of x plus f of x equals f of 2x. Which one of the following is a possible rule for the function? So you see one of these questions on almost all of the multiple choice sections. And the way I usually go about this is I just define each of these functions and then I try to put this in. So I'll go f of x equals 1 minus x, and then I'll type in that whole thing. Equals f of 2x. And this one is not going to be the answer because it doesn't give us a true. But just looking at the answer options here, I can see that it's probably going to be C, because f of x plus x is going to be x plus x, which is 2x, which is also the same as f of 2x. But just to show you how it works on the CAS, I'll write it in again. So I do f of x equals x, and then I can essentially just copy this from 2 points above, and it tells us that it's true, and that's why the answer is C. So question 11 gives us the graph of y equals tan ax, and it tells us that there's a vertical asymptote at x equals 3 pi and exactly one x-intercept in the region of 0 to 3 pi, not inclusive. So since there's no translations left to right, we actually know that the x-intercept at 0 will not be counted in this equation because it doesn't include 0 to 3 pi. So therefore, what we're looking at is we just start with the base equation, which is just tan of x, and we know it has asymptotes at pi on 2 and 3 pi on 2. So then here we can see that if we multiply both of these by 2, we'll get our asymptote at x equals 3 pi and also at pi, and then there'll only be one x-intercept in this region. So therefore, the answer is going to be C. Question 12 tells us that the discrete random variable x has the following probability distribution, and then we have to find the probability that x is less than the mean. So first what I'll do is just calculate the mean. So I've got 9 on 20 plus 2 on 10 plus 3 times 1 on 20, 3 on 20 plus 18, plus 18 on 20. That gives us 17 on 10, which is roughly equal to 1.7. So the probability that x is less than the mean is going to be 1 on 4 plus 9 on 20, which gives us 7 on 10, which is E. So question 13 tells us that in a particular scoring game, there are 2 boxes of marbles, and the player must select 1 marble from each box. The first box contains 4 white and 2 red, so we've got 4 white, 2 red. And the second box contains 2 white and 3 red. And then each white marble scores -2 and each red scores +3. So what is the probability that the final score will equal 1? So here we have to get a white marble and a red marble, or a red marble and then a white marble. So this is going to be probability that white plus red plus probability that red plus white. So the first one is going to be 4 on 6 times 3 on 5. And then the next one is going to be 2 on 6 times 2 on 5. And we'll just put that into the CAS. And that gives us 8 on 15, which is E. Question 14 tells us 2 events are independent, and then they ask us what the probability of A is when they give you that probability of A and B, A union B is 0.52. So the trick with independent events is that probability of A times probability of B is equal to the probability of A and B. So here we can use the total probability equation to find out what PR of A is, because we get probability of A union B is going to be probability of A plus probability of B minus the probability of A and B. And here we know what probability of B is in terms of probability of A, so we can change this to plus PR 2A minus 2 probability of A times probability of A. And then I'll just put this into my CAS in a solve function. This is equal to 0.52 is equal to, let's just say A plus 2A minus 2 times A times A, which gives us 1 on 5, or 13 on 10, which is going to be B. Then we've got question 15, which gives us a probability density function, which is given by this, and then we need to find the median. So for this one, I'm just going to, I think what I'll do is I'll integrate this from 0 to m, and then that gives us that answer here. So we get negative m squared minus 16 on 48, and this is going to be equal to 1/2. So now what I can do here is I'll just multiply this side by 48. We'll get negative m this plus m squared, 16m squared is equal to 24, and that essentially gives us the answer E, which is just this rearranged. So question 16 is an approximation question, and we're given the area of the area between the x-axis and the graph of that, and then we're asked to find her approximation as a fraction of the exact area. So what I'll do first is I'll find the exact area. So shift plus to get integral pi on 2, and we got 2 times cos 2x plus 3 dx. That gives us 3 pi on 2. And then here we've got to do base times height for each of these rectangles. So we've got 4 times pi on 6, so 4 pi on 6. Then this one is also going to be pi on 6 base. It's not pi on 3, that's the trick. And so we got 2 pi on 6, and then this one we got just pi on 6. So those three added up together is going to be 7 pi on 6, and then we divide 7 pi on 6 by 3 pi on 2, which will give us 7 on 9, which is B. So now we've got question 17, which tells us that the turning point of the parabola is closest to the origin when b equals whatever. So I know that with quadratic functions, the turning point is going to occur at x equals negative b on 2a. And in this equation, it's going to be 2b on 2, which is just b. But we can't just say b equals 0 because that might be further away from the origin. So now what I'll do is I'll sub in b into this equation here. And what I'll do b squared minus 2 times b plus 1. That gives us 1 minus b squared. So then the distance is going to be the root of that squared plus b squared. And then what I'll do is I'll use the minimum, function minimum of that, comma b, to get the answer, which is plus or minus 1 on root 2, which is c. Okay, so now we've got question 18 where there's a lot of parameters. So we're looking at these two functions in the positive real numbers, and then where all of these are positive integers. So if x such that f of x is greater than g of x equals for 0 to 1, and g of x is greater than f of x for 1 is greater than 1 to infinity, which of the following must be false? So what this is essentially saying is one of the functions looks like this, and one of the functions looks like this. And because they're all x to the power of something, this point of intersection is going to be 1, 1. Because x to the power of 1 is always going to be 1. When x equals 1, 1 to the power of anything will always be 1. But what's important is the behavior between 0 to 1 and from 1 to infinity. So if the fraction here is greater than 1, for example, it's something like x squared or x to the power of 3, it's always going to look like this equation here. And what they're telling us is that they want this equation to be g of x. So we want this to be g of x. And whenever the fraction here, m on n, is less than 1, the function will look like this, and we want this to be f of x. So that tells us that m on n must be less than 1, and p on q must be greater than 1. And that, from that, we can get p is greater than q, and m is less than n. And then therefore, we can also get the answer that p times n is going to be greater than q times m. So since the question asks us to find which of the following are false, now we know that C cannot be right because it would actually be the other way around. We also know that A cannot be right and B cannot be right because we've already we've gone through these equations, and this is the only relationship that we can get from them. And now we're looking at D and E. So for D, we're looking at this part of the graph here. And for this, we can actually see that it is true, because at some point here, there will be like these tangent lines that have the same gradient. But E, on the other hand, is not true because once we pass 1, our tangent lines can never be the same. So that's why the answer to 18 is E. Okay, so now we've got question 19, which is essentially a integration question, it looks like. So they've given us the graphs of each of these functions here, and we've got an integral expression that gives the total area of the shaded regions is whatever this is. So what we're going to look at here is this part from 0 to 1/3 is going to be f of x minus g of x. So this is going to be f of x minus g of x because f of x is on top. So I think we know straight away that a and b cannot be right. Then from 1/3 to 1, we get g of x minus f of x. And this area here is going to be the same as this area because we know that trigonometry functions are usually symmetrical. And then we've got from 5/3 to 3, we also get g of x minus f of x. So if we have a look here, we're going to look at, E looks the most right to me at the moment. So we've got 0 to 1/3, g of x on f of x minus g of x, so that's right. Then we've got g of x minus f of x times 2 from 1/3 to 1. And then we've got 5/3 to 3 of g of x minus f of x. So this one is unfortunately not right because this is mixed up. So now we'll look at C, which is the next one that looks somewhat right. So we've got 0 to 3 f of x minus g of x. So that is correct. So this part is right. Now we've got the next part, which is -2 times 1/3 to 1 of f of x minus g of x. So here what's interesting is they've calculated this area here, which is, they've calculated the negative of this area, but they've also put a -2 here. So this is actually correct. And then we've got minus 5/3 to 3 g of x minus, this is f of x minus g of x. So again, they've done the same thing where they've done the inverse, but they've put the minus here, which calculates for it. So the answer is C. So now we're on question 20, which tells us that there's a probability density function. The median is at x equals 0 and the gradient is 4. And now they've changed it so that the gradient is -1 and the median is still at 0. So we're essentially looking for the transformations that changed it from 4 to -1. And because it's a probability density function, the negative here can only come from a reflection in the y-axis, because if you reflected it in the x-axis, there would be a negative probability, which is impossible. So therefore we know that it can't be C and it can't be B or E because they all reflect in the x-axis. So now we're essentially looking for which one out of A and D is correct. And first we have a dilation from the x, and then we have a dilation of a half from y. And we know that because a dilation of 2 from x would spread the graph out, that would make the gradient lower, so it must be A. So that's the multiple choice done. I hope you guys found that helpful, and now we'll move on to the extended response. The first thing that I actually recommend anyone does when they start an extended response question is actually make a new problem on the CAS. So the way you do this is you press doc, insert, problem, and here essentially in a new problem, all of your functions that you save will be the same and independent from the other problems that you have in the paper. So this question we have a quartic f of x equals 3x to the power 4, blah, 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 and the graph of f of x below. Find the coordinates of the point M at which the minimum value of the function occurs. Okay, so here what I'll do is I will first define this function. So we've got 3 times x to the 4 plus 4 times x to the 4. So that's our f of x defined. And to get part A, I'll just do menu for function minimum f of x, comma x, and that will give me x equals -2, and I'll go f of -2. That gives me answer -2, -32. State the values of b for which the graph of y equals f of x plus b has no x-intercepts. So that is going to be, since we know that the minimum is -32, and that's this point here, m, therefore we know that b is just going to be greater than 32, so therefore b is an element of 32 to infinity. And you can't include 32, because if you included 32, there'd be one x-intercept, which would be the point m. Next, we're asked to find the tangent y equals f of x at x equals -1/3. So what I'll do here is I'll use the tangent function on the CAS. So menu for tangent line, f of x, comma, x equals -1/3. That gives us the tangent line y equals, I can zoom in, y equals 80x on 9 plus 41 on 27. And that's your tangent line L. So now we've got to find the tangent L intersects y equals f of x at two other points. State the x values of the two other points of intersection. Okay, so this one is fairly easy. We just have to do L of x equals f of x. So I'm actually going to define L here. So we've got L of x is equal to that, and that will define it. And then what I'm going to do is I'll write this out on the paper. Is equal to f of x. So f of x is whatever, all of that. So I'll write that in. And then what I'll do is I'll just solve this by putting this into the CAS. So 1 L of x is equal to f of x, comma x. That gives us negative those roots. So they asked us for the answers in the form a plus or minus root b. So now what we can do is we can expand this and we'll get, we know that root b is going to be root 42, c is going to be 3, and then therefore we have -1 just from expanding those brackets. So state the x values of the two other points of intersection. We get x is equal to -1 plus or minus root 42 on 3. And now we're looking for the total area of the regions bounded by the tangent L and y equals f of x. So this isn't too bad. This is just these two areas. And we know what the bounds are. So essentially all we have to do is just write out these integrals. So what we'll do is we've got our first integral is going to be from -1 minus root 42 on 3 to -1 on 3. And all of these are going to be L of x minus f of x. But just remember, we haven't actually defined L in this thing, so we have to actually write it out, which is 80x on 9 plus 41 on 27 minus f of x dx plus, now we've got -1/3 to -1 plus root 42 on 3 on 27 minus f of x dx. And now I'll just put this into my CAS, which will give me, so we'll make sure to write this in correctly. So -1 minus That gives us our first part, which is this part here. And then now we've got to do our second part, which is which gives us that, and now we'll just add these two together, which gives us 784 root 42 on 135. That's a really ugly number, but sometimes you get that in methods. Sorry, my battery died, so I had to switch it out. But now we're up to part F, which has this function p, and p of x looks very, very similar to f of x. And so we've been asked first to state the value of a, for which f of x equals p of x. So firstly, I'll have a look at what f of x is. And as you can see, the difference between f of x and p of x is that there aren't these two here. And then also this is equal to negative 12. So I know that since these two don't exist in f of x, a must be equal to 0. Next, we're asked to find all solutions to p dash of x equals 0 in terms of a where appropriate. So what I'll do here is I'll define p of x, which gives us 3x to the power 4 plus that's p defined, and then what I'll do is I will find the derivative of p of x, and I will make this equal to 0. And then I'll solve for x because we're finding things in terms of a. So that gives us 3 answers. X equals 1. X equals negative 1 plus or minus root 1 minus a. Then we've got to find the values of a for which p has only one stationary point. So what this is asking us to essentially do is, because this has a square root in it, there will be values of a for which this solution doesn't exist, and because of that, there'll only be one solution. So the values of a for which p only has one stationary point are going to be when 1 minus a is less than 0. So when a is an element of infinity, 1 to infinity. And the reason I can't put 1 including is because if a was 1 here, then there would be 2 solutions, which is x equals 1 and x equals negative 1. Find the minimum value of p when a equals 2. So what I'll do for this question is I will do menu 3 function minimum of p of x, comma x, given that a equals 2. That gives us x equals 1, and I'll do p of 1, and then we'll take this and we'll do a equals 2 again, and that gives us negative 13. Alright, so now we're looking at this last question, which is if p has only one stationary point, find the values of a for which it has no solutions. So since there's only one stationary point and we're looking for no solutions, then we know that that stationary point has to be the minimum, because otherwise there would be solutions no matter what value of a it was. So therefore we know that the minimum must be at x equals 1, which we calculated before. So therefore, what we'll do is we'll do p of 1, and we'll find what this is equal to. So this equals to a squared minus 6a minus 5. And then essentially what we need to find is a squared minus 6a minus 5 is greater than 0. And I'll put this in here. A, that gives us a is less than 3 minus root 14, or a is greater than 14 plus 3, root 14 plus 3. But if we remember from before, if p has only one station point, a must be between 1 and infinity. So therefore it cannot be this answer, and it has to be a is greater than root 14 plus 3. Okay, so now we're up to question 2, and again I'm going to make a new problem so that I don't have to redefine my variables on the calculator. So we have a drug X comes in 500 milligram tablets. The amount of the drug is that, and find the time in hours taken for drug X to reach a maximum amount in the bloodstream. So what we essentially have to do is just find the maximum of this function. So what I'll do is I'll do b dash of t is equal to 0. And then we have to do, we'll just define this function here. So we'll go b of t is equal to So I've defined that equation here, and then now what we're looking for is to get the function max. So I'll use the function maximum b of t, comma t, and then we get our answer. T is equal to 10 on 7 log e 9 on 2. Okay, so now we'll move on to the next question. The graph of b of t is shown for 0 to 6. Find the average rate of change of the amount of the drug in the bloodstream over the interval 2 to 6. So we have to give this to one decimal place. So the average rate of change is going to be f of 6 minus f of 2 on 6 minus 2. And we'll just write this in. So I wrote f, which is not right, it's b. So I'll make sure to write b in, actually. So b of 6 minus b of 2. So I'll put that into the cas. We get b on 6 minus b on 2 on 6 minus 2. And we'll approximate it. So we get negative 33.5 since they say to one decimal place. So yeah, got negative 33.5. in milligrams per hour. So now we need to find the average amount of drug X in the bloodstream during the first 6 hours. So this is essentially asking us for the average value. So that is going to be 1 on 6 minus 0, 0 to 6 of b of t dt. And this is going to be equal to, we'll just put this in the cas, 1 on 6 times 0 to 6 b of t dt. Control enter, 255.9. But they ask for the nearest milligram, so 256 milligrams. Then we're told 6 hours after one 500 milligram tablet is consumed, a second identical tablet is consumed. Then they tell us that the amount of drug X in the bloodstream is shown on the graph below. And then we've got to sketch the total amount during the first 12 hours. So now, since we've got to add these two functions together, we can draw them by just getting the correct, the best points to look at. So what we get is, we get this here, which is this point here, because it starts at 0, and then we're adding it to here. And then we've also got these two points added together. So that will be double that. So we'll get around here. And then we've got the whole function just being added together. So it will follow tablet 1 for the first bit. And then it will shoot upwards. And then it will sort of follow that part of the graph. So that's just a simple addition of functions, and that's how you would graph that. So now we're looking to find the maximum amount of the drug in the bloodstream in the first 12 hours and the time at which the maximum occurs. So what this is going to be is it's going to be this function plus this function somewhere in this area here. So the way we achieve this question is we have to look at what this function is actually moved across by. So tablet 2 is really just tablet 1 moved across by 6 hours. So if you think about what that function would look like, it would probably be b of t minus 6, which would move it across by 6 hours. So what we'll do is we'll define this function as b2 of t equals that. And that is going to be tablet 2 and the function for tablet 2. Now what we're looking at is going to be the first tablet plus the second tablet, and then we're looking for this point here on the graph, which is the maximum. So what I'll do here is I'll do b of t plus b2 of t equals that, and then we'll find the maximum here. And then for t, but we'll put in the definition that t is between 6 to 12. And that gives us our answer to 2 decimal places, 7.78. So what I'll write this as is second tablet equals b of t minus 6, b of ddx of b of t plus b of t minus 6. My b's and 6's look the same, but equals that, and then we get t is equal to 7.78. I hope that makes sense. Okay, so now we're up to question 3, which is another short answer question. So what I'll do is I'll make another new problem on the CAS, and then I'll add a calculator. So here we've got a horizontal bridge is positioned 5 meters above ground level, and it's 110 meters in length. We're given this information about the arches, and then we're given 3 big functions, which is a bit annoying, but then we asked to find the value of A, which is in arch 3. So I think this isn't too bad because we've got arch 1, it goes from 5 to 35, and it's x minus 5. This is from 40 to 70. This is x minus 40. So if this starts at 70, this must start at 75. So therefore A is equal to 75. Next, we're asked to describe the transformation that maps the graph of y equals h2 of x to h3 of x. So this is looking at from negative 40 to then negative 75. So that's going to be moving 35 to the right. So we'll just describe that as that. So translation 35 units to the right. Now we're given the next thing to do. So the area above ground level between the arches and the bridge is filled with stone. The stone is represented by the shaded regions. So we're trying to find the total area of the shaded region. So first thing I'll do is just find the area under the bridge. So we've got 5 times 110. So area under bridge, just call that, equals 5 times 110. And that is going to give us 550. And then what we'll do is we'll just find the area of one arch because we know all 3 of the arches are the same. So let's type in arch 1. I'll actually define that in the CAS. So I'll go h1 of x is equal to 5 times sine of x minus 5, sorry, typed in the wrong thing, x minus 5 times pi on 30. That gives us that equation. Then we'll do 5 to 35 h1 of x dx. That gives us 300 on pi. So area arch 1 equals to 535 h1 of x dx equal to 300 on pi. Therefore, total area equals 550 minus 3 times 300 on pi, which is going to be, and we have to find it to the nearest square meter, so do that times 3, 263.5, so 264 meters squared. So now we move on to the next part of this question. We're told that there's another bridge with a height of 5 meters above the ground, and it has an incline of a constant angle of elevation of pi on 90 radians. Then we're also told that there's arches, and they're the same as the arches in the first bridge, and then we need to find the gradient of the second bridge to 3 decimal places. So I know that this is going to be tan of this angle because we're given the angle, and the reason it's tan is because tan is opposite on adjacent, and opposite on adjacent is the gradient. So we get tan of pi on 90, and that is equal to, we'll type that in, oops, that is equal to 0.035. So correct to 3 decimal places. Yeah, that's right. So 0.035. Then they tell us that P is a point on arch 5. The tangent to arch 5 at the point P has the same gradient as the second bridge. Okay, so we have to find the coordinates of P. So we're told that arch 5 is the same as arch 2 here. So I'll just get this equation and type it in. So we got that, so we typed that in and we defined it. So now what we're looking for is we're looking for the derivative of this function. And we'll get the derivative of that, that gives us that. And now what we're looking for is the value of this that is equal to 0.035, which is the answer we had before, comma x, and then we have to remember to put the restriction on the domain of x, because otherwise we'd get lots of different answers. So I'll just write down what I'm doing. So we get h2 dash of x is equal to 0.035. And then now what we're looking at is x is equal to, so we also have the coordinates, which is from 40 to 70. So 40, that gives us 54.36, and then 2 decimal places, yeah, 54.36.36, and then we have to find the coordinates, so we shouldn't forget that. Put that in here. .988, so H2 of 54.36 is equal to 4.988. That gives us the coordinates 54.36 and then 4.99. Okay, so now we'll move on to part F, and this tells us that a supporting rod connects a point Q on the second bridge to a point to the point P on arch 5. The rod follows a straight line and runs perpendicular to the second bridge as shown in the diagram on page 18. So that might be the next page. No, it's the previous page. So, that's the point Q here. Now we're told to find the distance PQ in meters correct to 2 decimal places. So what we'll do here is we actually have the point P, and we're looking for a line that is perpendicular to P because P is also parallel to the second bridge. So what we've got is we've got this point here, and we'll find the equation of the normal to H2 at that point. So normal at point P. So then what we can do is we have this point P, 54.36. So we'll just write that out, 99. And then we'll essentially just put this into the CAS. So got that, we're looking for a normal, which is A, to H2 of X, comma, X equals 54.36, and then we'll press enter. So now we got the equation of this line. So we've got normal equation is y equals negative 2.091 x minus 4066.16. And now we're looking to find the equation of the second bridge as well. So we have the gradient of the second bridge and we have the y-intercept. So line second bridge is equal to y is equal to the gradient plus the y-intercept, so 0.0535x plus 5. And now we find the intercept between these two lines. So we got that equal to 0.035 times x plus 5, comma, x. That gives us x is equal to a weird number, which is not right. So I'll have a think about this question and come back. Okay, so I had a quick look at what I had made a mistake in. It was just this part of the CAS here, this normal line here. So I made a mistake. I typed in times negative 3.6, so that was not what it was supposed to be. It was just 54.36. So 54.36, that will give us the correct normal line, which is that. And from here, we can actually do that equation. So these are just the little mistakes that you can make for sure in any methods exam. So got that is equal to this point here. So I'll actually rewrite this in. So the gradient, the normal equation is going to be negative 28.5179x plus 15522, and then we've got this line of the second bridge is equal to 0.035 times x plus 5 comma x. That gives us the point of intersection 54.29, so x is equal to, and now we have to try and find the y point here. So we'll go 0.035 times x plus 5, given that x is equal to that. That gives us y is equal to 6.9. So now what we're looking to do is find the distance between these 2 points. So distance to 9, comma 6.9, and our original point, which was 54.36, 4.99, And now we'll just use our distance formula to get the difference between these 2 points. So we'll go 54.29 minus 54.36 squared plus 6.9 minus 4.99 squared. That gives us 1.91, correct to 2 decimal places, meters. All right, so now we're moving on to question 4. We've got doctors are studying the resting heart rate of adults in 2 neighboring towns. We've got a mean of 68 and it's normally distributed and a standard deviation of 8. Find the probability that it's between 60 and 90, correct to 3 decimal places. So as usual, I'm gonna make a new problem and then I'll just use the binomial, the normal CDF and go from 60 to 90. The mean was 68 and the standard deviation was 8, which gives us 0.838. Next, we've got the probability that someone has a slow heart rate is this. 29% play sport regularly, 9% have a slow heart rate and play sport regularly. And then we've got S is sport regularly, H is slow heart rate, and we're finding H given S. So probably that H given S is going to be the probability of H and S over probability of S. And this is going to equal, H and S is 0.909. And the probability that they play sport is 0.29. So that is going to be 0.310. So now they tell us, are the events H and S independent? So what we'll do is we'll write out PRH S is equal to PR H and S on PRS. And if they're independent, we know that PR H and S should be probability of H times S. So this is not the case. So we get H times probability S on probability S. So is not equal to the probability of H because we have probability that they have a slow heart rate is 0.1587. So we do not get that because this is not equal to 0.1587 and therefore not independent. Now we'll move on to the next question, which is part C. Find the probability that a random sample of 16 Mathsland adults will contain exactly 1 person with a slow heart rate. So what we look at here is that we have slow heart rate is 0.1587, so 0.1587 slow heart rate. Now we're looking at 16 Mathsland adults and exactly 1. So this is going to be a binomial distribution. So we got a binomial distribution with n equals 16 and the PR is equal to probability is equal to 1587. And then we'll essentially put that into the calculator. So we've got probability 5 distribution, binomial PDF, since it's only 1, so we have 16, probability of sex is 0.1587, and the x value is 1. That gives us our answer is, so we'll actually write this out properly, 16, 0.1587, PR is equal to 0.190, correct at 3 decimal places. So now with this question, we're given a total sample of Mathsland adults. Got p hat is a random variable and find the probability that p hat is greater than 10%. So 10% is going to be 0.1 times 16, which is 1.6. So probability that p hat is greater than 0.1 is equal to the probability that x is greater than 1.6, which is equal to the probability that x is greater than equal to 2. And this we can put into our CAS again. And we've got binomial CDF, 16 trials, probability of sex 0.1 to 1587. Lower bound is 2, upper bound is 16. Then we get 0.747 to 3 decimal places. So with the third part of this question, we have samples of n Mathsland adults. P hat on n is a random variable that represents the proportion of people who have a slow heart rate. Find the least value of n for which probability of p hat is greater than 1 on n is greater than 0.99. So I think the trick with this question is to figure out what it actually means. So let's just think about this middle part here. So p hat is greater than 1 on n means that, for example, if there were 30 people in the proportion is the number of people who have a slow heart rate. So if that is greater than 1 on 30, that means that one person out of the 30 had a slow heart rate. So therefore, what we're looking for in this question is the number of people required so that the probability that more than one person has a slow heart rate is greater than 0.99. So the way we go about doing this is we say that probability of p hat n greater than 1 on n is equal to the probability that x is greater than 1, which is equal to the probability that x is greater than equal to 2. And that we want this to be greater than 0.99. So this is essentially telling us that probability of x equals 0 plus probability that x equals 1 is less than 0.01. And now this we can work out fairly easily on the CAS. And the way we do this is we hit menu. First we actually define a function. So we go bin n is equal to menu 55 b. So this is binomial CDF. We have n trials. Probability of success is 0.1587 from above. Then we have our lower bound 0 and our upper bound 1. And then we put this in. And now what we do is we make a new spreadsheet. So we go to list and spreadsheet, and then we press Control T, and then we select bin. And then we go all the way down, and we're essentially looking at this bottom number to see when it goes below 0.1. And that is pretty soon at 39. So at 38, it's 0.11. 39, it goes below 1. So therefore, n is equal to 39. The doctors took a large random sample of adults in the population and calculated an approximate 95% confidence interval. They got this, and we're looking for the sample proportion used in the calculation. So now what we're looking for is the sample proportion is just going to be the number in between these two. So we just go 0.102 plus 0.145 on 2. That gives us 0.1235 is the sample proportion they used. Explain why this confidence interval suggests that the proportion of adults with a slow heart rate could be different from the proportion in Mathsland. So the proportion in Mathsland is not in the confidence interval, which is the reason why it's not. It's probably different. So okay, so now we'll move on to the next question. Every year there is blah blah a hike probability density function with that rule, and then find the expected time for a randomly selected student to reach the top of the hill. So this is just going to be the mean of this probability density function. So what we'll do is we'll just define this on our CAS. So we got m of t is equal to 3 on 50 So we defined that. Now we're just going to go from 0 to infinity, infinity of m of t times t dt. And we're looking for an answer to one decimal place, so we'll just Control Enter. Got 44.6. So 0 to infinity, 3 on 50. That is equal to 44.6 minutes. So now we've got the next question, which is students who take less than 15 minutes to get to the top are considered elite. Oh, we just have to find the probability to 4 decimal places. So this is just going to be 0 to 15. Yep, 0 to 15 m of t dt. And we'll just put that into the CAS, 0 to 15 m of t dt. That gives us 0.0266. Part G, the Year 12 students at Mathsland make up 1/7 of the total number of students. 5% are categorized as elite. Find the probability that a randomly selected non-Year 12 student is elite. Give your answer to 4 decimal places. Okay, so that we know that the Year 12 students are 1/7, and we also know that therefore the rest must be 6/7, they all combined must make up, elite students must make up 0.0266 of the whole school. So therefore, if the proportion is x, for example, we have 1 on 7 times 0.05 plus 6 on 7 times x is equal to 0.0266. So from this we can calculate x. 1 on 7 times 0.05 plus 6 on 7 times x is equal to 0.0266 on x. X is equal to 0.0277, so which is the answer to this question. Okay, so now let's move on to question 5, which is going to be the last question of this paper. I made a new problem on my CAS, and so what I'll do here is we have these two functions and we're trying to find the coordinates of the local maximum of f in terms of a. So here I'm going to write f of x, f dash of x is equal to 0. And then what we're looking at is, I'll define this function on my CAS. A to the power 4. Sorry, it's 4a to the power 4. A to the power 4. And now we're looking to find the coordinates of the local max. So I'll use function maximum of f of x, comma x. That doesn't give us an answer, so that means we have to do the derivative way. That gives us that. We'll make this equal to 0. X, and we'll get x equals 2a on 3 or x equals 0. So now we have to find out which one of these is going to be the local maximum, but I can tell that x of 0 is just going to be 0. So I'm assuming it's going to be the other one. So we get x equals 2a on 3, x equals 0. And a is a positive real number, so it's more likely to be that. Now we go f of 2 times a on 3. that gives us 3 on A. Therefore, the coordinates are going to be 2A on 3, 3 on A. So now what we do is we find the x values of all points of intersection between the graphs of f and h. So now I'll have to define h as well. So we've got h of x is equal to 9 times x on 2a squared. Then we'll do solve that for x, comma x. Then we get x equals 2a on 3, x equals 0, x equals a on 3, and x equals 2a on 3. Those are our 3 points of intersection, 3 x values. So now we have to find the total area of the regions bounded by the graphs of y equals f of x and h of x. So looking at this, it's very likely that since the local maximum of f is at 2a on 3, it's likely that the way the graph will look will be like where f of x is greater than h of x. So the way I think it will look at the moment is probably something like this, and where we've got something like this, where we've got h of x going like that. So we're probably looking for, more like that. So we've got these two here, areas. So the way I'll look at this is I'll do 0 to a on 3 of 0 to a on 3 of h of x minus f of x. And then I'll calculate that. H of x minus f of x dx. That will give us 1 on 16. And then we'll do a on 3 to 2a on 3 of f of x minus h of x. And we'll see what that gives us. And that gives us 1 on 16 again. That gives us total area is equal to 1 on 8. Okay, so now we move on to the next part. We've got a new function g, 0 to 2a on 3, which is the last intersection, and where g is exactly the same as a was. So I'm going to define g on my CAS. So we've got that, got 81 times x squared times a minus x on 4 times a to the power of 4. Got that. Now we're just going to do 2 times a on 3 times g of 2 times a on 3. And that gives us 2. So now they ask us to find the area bounded by the graph of g inverse, the x-axis, and the line x equals g of 2a on 3. So what this essentially is if we visualize what this will look like, if we have our g of x, which would be something like this, for example, our g inverse of x is going to look like this. And so then the area that they're actually asking us to get is pretty much this area here, because the line x equals g of 2a on 3 is going to be a vertical line, and they're trying to get this area. But since we don't know what this is, instead of finding this area like that, what we can do is we can try to find the area of the normal function from here and this. So what we'll do is we'll get this whole rectangle and then minus this area underneath. So the way we do that is we do g of 2a, which is a on, which is, let's have a look. I'm pretty sure which is 3 on a. So we do 3 on a times 2a on 3. So this would be 3 on a, and this is 2a on 3, minus 0 to 2a on 3, g of x dx. And this gives us, let's multiply this together. We've got 3 on a times 2 times a on 3, which is 2, and we go minus 0 to 2 times a on 3, g of x dx, and that gives us an area of 1. Now we have to find the value of a for which g and g negative 1 have the same endpoints. So we know that the endpoint is 3a, so we got 3a is equal to 2a on 3. That gives us a is equal to a, and we know that a has to be positive, so it's plus or minus 3 root 2 on 2, but a is greater than 0, so a is equal to 3 root 2 on 2, and we'll check what it is. A is a positive real number, so a is just greater than 0. So now they ask us to find the area enclosed by the graphs of g and g inverse when they have the same endpoint. And now what we'll do is we'll just define a to be 3 times root 2, root 2 on 2. And then what we have to remember is that the graph of g actually crosses at a on 3. So that's what we remember from here, f and h. And a on 3 is a point of intersection. So what we do is we do the integral 0 to a on 3 of g of x minus x dx, which gives us 1 on 16. And then therefore we just multiply this by 4, because the way our thing will look like is if we have our equation, it's going to look like this. And what we've essentially calculated is this area here, but it will be the same in all 4, even though my drawing is bad. So we get 1 on 16 times 4 equals 1 on 4. And that is the end of this paper. If you guys found this video helpful, do drop a like on the video and subscribe to the channel. And if you haven't already, make sure to check out the video where I go through the exam 1 on this exact paper.